Hello, we are going to start our new unit today, which is going to be all about how to solve quadratics and different methods to do that. So quadratics, these are going to be your x squared equations. So we are going to be focusing on things that have the form like ax squared plus bx plus c, where a, b, and c are going to be numbers. Or sometimes it might just be an x squared. Maybe you just have like an ax squared plus a number, but it has to have the x squared in it. So quadratics means it has an x squared. So today we're going to be focusing on how to solve quadratics using the square root method or using square roots. So these are going to be when you have quadratics in this format. So ax squared plus c. So notice that the bx part is missing. We just have the x squared and then a constant c term. Sometimes you'll see it in this format as well. We'll get to that, but most of the time it'll just look like this. So we are going to be using radicals, which again, radicals is just a fancy way of saying your roots. So we're going to be using square roots. Okay, my printer was a little bit crazy today. So when we are solving equations, don't forget that when you take a square root, it has two possible answers. And what I mean by that is if I take the square root of 4, square root means what number times itself equals 4. Well, 2 times 2 is 4, right? We know 2 times 2 is 4. So we would say, oh, the square root of 4 is 2. But negative 2 times negative 2 also equals 4. So one of the answers for the square root of 4 is negative 2. You always have the positive and the negative version of that, since two negatives make a positive. A lot of people forget this, and especially when we're doing like simple square roots, like something like 4, like, oh, it's just 2. But don't forget that it's negative 2 as well, or you might get half your answer wrong. So here's an example. X squared equals 64. If I want to figure out what x is, well, to get rid of a square, I would do the opposite, which is square rooting it, because a square root and a square cancel each other, and I would just get x back. But I would also need to take the square root of the other side to keep it even, so I would get the square root of 64, and we would say, oh, it's 8. But don't forget, 8 times 8 is 64, but so is negative 8 times negative 8. So we have two answers there. 8 squared is 64, and so is negative 8 squared. Careful with that. A lot of people forget those. So let's do this one. Square root of, or x squared equals 49. So to solve, you're going to take the square root, since the square root is the opposite of a square and they cancel with each other, and I get my x alone. But then the square root of 49, hopefully you guys have these memorized, is going to be 7 and negative 7. Okay, so that was an easy one because it was a perfect square. Let's do this one. Again, we're going to take the square root to get rid of that square. Those cancel with each other, and we get x equals the square root of 45. But 45 is not a perfect square, so we can't just spit an answer out like we normally do. When this happens and you come across a number that is not a perfect square, I'm not just going to let you guys do a decimal. You need to write the proper format. So if you remember at the beginning of the year, we spent a unit on solving and simplifying radicals. That's where this is going to come into play again. Whenever you get a number that's not a perfect square, I need you to do that little factor tree and think what is a perfect square that goes into that number. So for 45, what's a perfect square that goes into 45? Well, we know 9 times 5 is 45, right? So we can break up that square root of 45 to be the square root of 9 times the square root of 5. And 9 is a perfect square. So think of this as being the square root of 9 times the square root of 5. We can break them up into two little square roots. But the square root of 9 is 3. We know that 3 times 3 is 9. So we're going to take the 3 out. And then the square root of 5, I can't simplify that anymore. 5 doesn't break down anymore. It's a prime number, and it is not a perfect square. So we just have to keep that part inside the square root. So our answer here would be 3 square root of 5. But remember, I'm missing the negative version, -3 times the square root of 5. So you can write it separate like that. Some people do this little plus or minus symbol. That works too, where you would do plus or minus 3 times the square root of 5. Just same thing. We're just kind of smushing it together. That's kind of like the lazy way to write it. We're just doing the positive and negative once. So that's probably the easier way to write it. But don't forget that plus and minus. So another thing we're just going to touch on a little bit is imaginary numbers. Some of you guys might have heard of these and wondered what in the world are imaginary numbers. I think the name is a little bit misleading. They're not fake numbers. Imaginary numbers we get when we have to take the square root of a negative. So if you remember, we are not allowed to do the square root of negative numbers. So our workaround for that is imaginary numbers. So what we do is we say that whenever we come across the square root of a -1, we use this little I right here. And that's going to be kind of like a little variable we're going to use to work our way around taking square roots of negatives. So here's how we do it. If I have x squared equals -16 and I try to take the square root of that, in the past I would say, oh, can't do it, can't take square root of a negative, and we would just move on. But what we're going to do is we're going to think of this as being the square root of 16 times the square root of -1. But that -1 we're going to write as an I, a little cursive I. So we would get x equals the square root of 16, which is 4, and then we have that square root of -1, which is an I. And that would be your answer. Oh, and plus the little plus or minus. See, it's really easy to forget that. And that would be your answer. And for now, that is like the most we're going to do with imaginary numbers. You don't need to stress any more than that. Really, essentially, what you're going to be doing is just taking that negative and putting an I. Sometimes you might have something that's not just one step. So far, we've only just gone right to our square roots, but on these, you might have to like move some numbers around first. I can't take the square root of that square while this plus 8 is here. So let's subtract the 8 over first. So those cancel, and I have x squared equals -4, subtract 8, which is -12. And then now we can start taking the square root. But like on this problem up above, I run into that lovely negative problem. So what we're going to do is think of this as being a square root. And then 12 is also not a perfect square. So I'm going to write this as 4 times 3 times -1. I'm just kind of being a little tricky here with how I write my 12. Break it down into 4 times 3, and then I'm taking that negative, I'm going to do the -1. That way we can think of this as being the square root of 4 times the square root of 3 times the square root of -1. Well, we know that square root of -1 is our little I. So that's why I wanted to write it that way. So we're going to have a little imaginary I here. 4 is a perfect square. We know what the square root of 4 is. It's a 2. And a -2. We'll just do our little plus or minus 2. And then 3, well, 3 is kind of stuck in the square root. We can't do anything more. So we're going to have our plus or minus 2, our square root of 3, and our I. So when we put it all together, we would say x equals, and then usually we put the I with the whole number part. So I'm going to do plus or minus 2i, do your little I there, and then the square root of 3 on the back. And that's usually the more common way of writing that imaginary number. So that one is a little bit more tricky because you did have the I that popped up, and then 12 wasn't a perfect square, so we had to do our little factor tree to get it. So that's probably the most complicated version that you would see in your homework, is something like that. Okay, let's try a few more equations here. So what we're going to be doing is they're saying solve each quadratic using square roots. That means you're going to be solving for x. That's what it says, what it means when it says solve. And then we're using square roots because we have squares here, and the opposite of a square is a square root. This one does say find the exact solution. If there is no real solution, right, no real solution. So that means no imaginary. So sometimes you'll get directions like this where they're saying don't use imaginary numbers. So if you come across something like what we just did and it says no real solutions, then you don't need to worry about the i's. You would just say it doesn't exist. So sometimes those are nice when you get directions like that they're saying don't worry about the imaginary ones. But let's get started. Here we have x squared minus 16 equals 0. Notice the 16 is not over here. I'm trying to solve for x. So the first thing we need to do is start getting x alone by moving this minus 16 over here by adding 16. So I get x squared equals 16, and now I can take the square root of that. So I know the square root of 16 is 4 and negative 4. So do your little plus or minus 4. It's really easy to forget the negative version. So do that little plus or minus. Same on this one. Let's add the 25 over first. Kind of doing some easy ones here for you guys. You get x squared equals 25. Well, we take the square root. 25 is a perfect square. Square root of it is 5. But don't forget, we need the plus or minus 5 to get the whole answer right. Okay, x squared equals 64. We've already done this one. Hopefully you can just do it in your head. It's going to equal 8 and negative 8, or plus or minus 8. And then x squared equals negative 16. Well, here I would try and do the square root, but they said if there's no real solution, right, no real solution. So I don't need to worry about the i's on that one. But make sure to read your directions. If it doesn't say this, you still need to do the i's like we just practiced. Okay, again, my printer is a little bad here. It's supposed to say, remember when solving using square roots, you must isolate the square value. We need to get x squared alone before I actually do the square root. So I need to get that x squared alone by first getting rid of this minus 6 by adding 6 over. So now I've isolated that x squared, or got the x squared alone. And I get x squared equals 16. Take the square root, take the square root. Well, those cancel, and we get x alone equals the square root of 16, which is 4 and negative 4. And that would be your answer. Or you can do that little plus or minus 4. Notice on this one, though, the square is not right on the x. We've got these parentheses with the square on the outside. Right now, that means that square is isolated. I can't do anything to this plus 2 while it's being squared. So notice that the order is a little bit different on this one versus this one. When there, that 2 is in those parentheses with the square on it, it's kind of stuck in there. So we are going to go ahead and square root first this time. And that square and the square root cancel, so that x plus 2 is now out of those parentheses. But then here I have the square root of 4. Well, remember, the square root of 4 is 2 and negative 2. I'm not done solving my problem yet, though. And here I have 2 solutions. So we have to split it up. I need to do x plus 2 equal to the positive 2. But I also need to do x plus 2 equal to negative 2. Since I have 2 solutions for the square root of 4, I have 2 and negative 2. So we're going to have kind of 2 answers, but the order's all mixed up from what we were doing up here. So write your 2 equations and then start solving on each of these. So for this first equation, I'm still going to get rid of that plus 2 by subtracting 2. Those cancel, and I get x equals 2 minus 2, which is 0. So there's one answer. But then I still need to do the x plus 2 equal to the negative 2. So subtract that 2 over to get x alone, and we get negative 2 subtract 2 is negative 4. So careful with that. Sometimes they'll try and trick you by putting the order that you do your order of operations different. Okay. And then I don't think we'll do all of these just for sake of time. So let's just pick a few of them. But we're going to solve each of these, and notice it does say if there is no real solution, just write no real solution, so we don't need to worry about imaginary numbers on this set of problems. So let's do number 5. So first, we're trying to isolate x squared, get this alone to solve for x. So add the 54 over first. So we have 6x squared equals positive 54. And then now we can get rid of that 6 by dividing. So we get x squared is equal to 54 divided by 6, which is 9. And then now we can take that square root, and the square root of 9 is 3 and -3, or do your little plus or minus 3. Don't forget the minus part. Okay. Let's do number 7. Again, we're trying to get x squared alone first. So let's subtract 7 over, and we get 3x squared equals 22 minus 7, which is 15. Then now we get rid of that 3 by dividing. We get x squared equals 15 divided by 3, which is 5. And then we take the square root, and we get x equals the square root of 5. Well, 5 is not a perfect square. It's a prime number. I can't break it down anymore. So what do? I can't really do anything. I don't want a decimal number, so we're just going to have to leave it in the square root. So I'm going to still write my plus or minus, but then just keep it as a square root of 5, and that's going to happen sometimes. But the only time that's going to happen is when it is a prime number, and you can't break that prime number down anymore. So careful with those, but it is okay to leave some of them in square roots. Don't put a decimal unless they tell you to put a decimal. And then let's do number 10. Since the order on this one's a little bit different. So again, we're trying to get x squared alone, but I can't get rid of this minus 2 while this 6 is being multiplied on the outside of everything. So our first step is going to get rid of that 6 by dividing by 6. So I have x squared minus 2 comes out by itself, and then 12 divided by 6 is 2. And then now I can get rid of this minus 2 by adding 2. So those cancel. And I have x squared equals 2 plus 2, which is 4. And now get rid of that square by square rooting both sides. The square root of 4 is 2 and -2. Or do your little plus or minus 2. And that would be your answer. So that is the square root method for solving quadratics. Again, they work when it's just an x squared and a number. So if I look back at that very first equation we were looking at, when it's just the ax squared plus c, x squared and a number, we don't have that bx term. We're going to learn in the next few days, what do you do if you have x squareds and x's and numbers? So those are going to be a different method to solve. So let me know if you guys need any help with solving those. I am happy to help you. Just send me an email and we can set up a Zoom time to go over questions together. Hope you guys are staying safe and healthy, and I will talk to you later. See ya.